Good morning, all of you. So, started with the new topic from group number 15 in P block elements, that is oxoacids of phosphorus. This topic is very important for your exam. So, oxoacids of phosphorus. What are these oxoacids? The acids which contain oxygen, and in these at least one hydrogen bonded with oxygen to describe acidic behavior of acid. It means only those hydrogen removed by acid which are connected with oxygen, not with the central atom. So here there are three elements are present in oxoacids. One is hydrogen, second one is oxygen, and third one is the other element whose oxoacids you studied. Now some other points which we have to remember while writing their name, that is we will see a point here. The word is pyro. So when does it used? It is used when one water molecule is removed from two small molecules of oxoacids, then pyro word is used. Second word here is used is meta. When one water molecule is removed from one small molecule of oxoacid, then name of the oxoacid is started with meta. And another word is hypo, used for those oxoacids in which oxidation state of element is least. Okay, not all the time. It is our point to learn the oxoacids of phosphorus or hypo. Somewhere it is related with the least oxidation state and somewhere it is not. So we see these oxoacids one by one. Started with first one, that is H3PO2. Here if you calculate the oxidation state of phosphorus, then it becomes +1. The least oxidation state shown by phosphorus in its oxoacids, hence it is started with hypo. So its name is hypophosphorus acid. hypophosphorus acids. Now draw its structure, then choose the first central atom, that is phosphorus. Put one oxygen with double bond. The remaining elements, 3 atoms of hydrogen and 1 atom of oxygen. Now after that, put one OH bond with central atom. After adjusting these elements, we are remaining with 2 atoms of hydrogen. So these 2 atoms directly linked with the phosphorus. This is the structure of hypophosphorus acid. It is also named as phosphinic acid. Phosphinic acid. Now discuss about the basicity of this acid. Then only those hydrogen removed as H positive which are bonded with oxygen, as here the electronegativity difference is more than the electronegativity difference between hydrogen and phosphorus. So it is not possible to release these hydrogen, but yes, it is possible to release that hydrogen easily which is connected with oxygen. So its basicity is 1. Hence it is called as monobasic. So hypophosphorus acid having 1 double bond O, 1 single bond OH and 2 single bond hydrogen. Next one is H3PO3. So now the here oxidation state of phosphorus, if you calculate, then it is +3. With it we discuss other oxoacid, that is H3PO4, and here the oxidation state of phosphorus is +5. So phosphorus in these oxoacids, the lower oxidation state, then the acid is end up with us acid, and if phosphorus show higher oxidation state, then it is end up with ic acid. So names are, it is called as phosphorus acid and it is called as phosphoric acid. They may be started with ortho, or they may be started with orthophosphorus acid, and another name for it is phosphorus acid. It also be called as orthophosphoric acid, isn't it? Now discuss about the structure. Then first of all, the central atom and 1 oxygen with double bond, remaining 3 hydrogen and 2 oxygen, so it has 2 OH bond. After that we are remaining with 1 hydrogen which is directly connected with phosphorus. So for basicity, focus on those hydrogen which are linked with oxygen. So its basicity is 2. It is called as a dibasic acid. Isn't it? And for phosphoric acid, about its structure, then here is the central atom. After putting these 2 elements, we are still remaining with 3 atoms of hydrogen and 3 atoms of oxygen. So put these with the phosphorus. Now its basicity it is 3. Hence it is tribasic acid. It is a tribasic acid. So next one here is H4P2O5 and H4P2O7. So these are formed by using phosphorus acid by 2 molecules of phosphorus acid, and it is prepared by 2 molecules of phosphoric acid. So let us now discuss, that is, here is the HPO3 plus HPO3, then collectively it becomes H6P2O6. Now what will we do? We have to remove one water molecule from these acids. It becomes H4P2O5. Is okay. So here is the one word which we use, that is pyro, when one water molecule is removed from 2 small molecule of oxoacid. Hence naming of this oxoacid is start with pyro, and end up with that acid from which it is formed, that is pyrophosphorus acid. Similarly with H4P2O7, taken 2 molecules of phosphoric acid, then it becomes H6P2O8, and when one water molecule is eliminated, it becomes H4P2O7. So again this one also started with pyro, and next one name of that acid from which it is formed. It is pyrophosphoric acid. Now if you calculate the oxidation state of phosphorus here, then it becomes +3, same as present in orthophosphorus acid. Okay, and in case of this one, it is the same as of phosphorus in phosphoric acid. Structure: here is 2 atoms of phosphorus, then put 2 atoms side by side. Next one, put double bond oxygen with these 2 phosphorus atoms. Now we are remaining with 4 atoms of hydrogen and 3 atoms of oxygen. Remember, if you separate this acid into 2 parts, these 2 parts must be same. So as we connect the bond with one phosphorus, same type of bond are present with other phosphorus. By putting these elements, we are remaining with 2 atoms of hydrogen and 1 atom of oxygen. So 2 same OH doesn't form. So what we do, put 1 hydrogen with both the phosphorus and connect these phosphorus with the remaining oxygen. This is the structure of H4P2O5. Now for this structure, that is same, put 2 phosphorus atom with double bond O, After this, we are remaining with 4 atom of hydrogen and 5 atom of oxygen. It means 4 OH bond are possible. So this one is OH, 2 with this phosphorus and 2 with this phosphorus. Remaining 1 atom of oxygen, it is present in between these 2 units of phosphoric acid. This is the structure of pyrophosphoric acid. Now what about basicity? Then count those hydrogens which are connected with oxygen. Then it is 1 and 2. Its basicity is 2, hence it is called as a diabasic. Here the basicity, same. Count those hydrogen which are connected with oxygen. 1, 2, 3, 4. So this acid is tetrabasic. ये कैसा होता है? टेट्राबेसिक होता है. Okay. Now next one is 6th. Is H4P2O6. For this, take 2 molecules of not the same, one of phosphorus acid and other one of phosphoric acid. Okay. The elements, the oxoacids taken here are not the same. One is of H4P2O5 and another one is for H4P2O7, phosphorus acid and phosphoric acid. Collectively it becomes H6P2O7. Now same, remove one water molecule. What we have now, there are 4 atom of hydrogen, 2 atom of phosphorus and 6 atom of oxygen. Here if you calculate the oxidation state of phosphorus, then it becomes +4. Okay, so how to remember this? Neither we taken 2 molecules of phosphorus nor 2 molecules of phosphoric. So what will we do? Then focus at third one, H3PO2. If they are not the single one, then use here. For this we use hypo. Phosphorus acid is used up, phosphoric acid is used up, then remaining is hypophosphorus acid. Then for it use hypophosphoric acid. Hypophosphorus acid we already done. Here use the hypo word, give the preference to the phosphoric acid, then its name is hypophosphoric acid. Structure, then 2 atom of phosphorus with double bond O. Now we are remaining with 4 atom of hydrogen and 4 atom of oxygen. It means here 4 OH bond are possible, 2 with this phosphorus and 2 with this phosphorus. Now there is no oxygen atom remain, so link these two units by phosphorus atom. This is the structure of H4P2O6. About its basicity, then its basicity is 1, 2, 3, 4. It is also the tetrabasic acid. Next one is, that is 7th, is HPO3. HPO3. This acid always present in polymeric form. But how to form it? Taken 1 molecule of phosphoric acid, that is H3PO4, and remove 1 water molecule. We are remaining with 1 atom of hydrogen, 1 atom of phosphorus, and 3 atom of oxygen. So when 1 water molecule is removed from 1 small molecule of oxoacid, then which word is used? Meta. Hence its name is meta, and formed by using the phosphoric acid, its name is metaphosphoric acid. Structure, then as we discussed, it is present in polymeric form. Taken its 1 polymeric form by repeating the same unit 3 times. So 3 HPO3 units linked with each other like this. This one is phosphorus, which is connected with 1 double bond O. Remaining 1 atom of hydrogen, that is, suppose it is OH. Now this 1 unit remaining with 1 oxygen, then put single bond with that. Second unit, it is linked with the first unit, hence here we taken the single bond, not the double bond, isn't it? Oxygen as it is a divalent. Now second one is this phosphorus, same unit, 1 it is linked with double bond O and OH. It's oxygen, it is a single bond O. That is the second unit. Now next one, it is connected with third unit, which is linked with a double bond O and OH, and third one, it's oxygen, which we connect with our first HPO3. This is the structure of HPO3, thus metaphosphoric acid. Now next one is H3PO5, and next one is H4PO oxygen 8. Their naming, it is done by the help of first draw its structure. Then here is the central atom, which is connected with phosphorus, 3 hydrogen, 4 oxygen, isn't it? So out of these 2 OH are present. If we here put 1 more OH, then the remaining oxygen is present with double bond. So in this case, phosphorus having more than 5 bond, which is not possible in case of phosphorus. Hence, what will we do? Put both the oxygen together and hydrogen at the terminal position. So this one is the structure of H3PO3. This connectivity is called as peroxo, that is peroxide ion, O2 2 negative. So due to the presence of this peroxo group, it is named as peroxo having the single unit of phosphoric acid, then mono phosphoric acid, peroxomonophosphoric acid. Basicity, that is, here 3 hydrogen are linked with oxygen, then its basicity is 3. It is tri-basic. And calculate the oxidation state of phosphorus. Here it becomes +5. Okay, just like this. It is the continuous series of oxoacids which is consisting of 2 molecules. Here is also, as we have 2 phosphorus, then put these 2 phosphorus with double bond O first, then we are remaining with 4 atom of hydrogen and 6 atom of oxygen. So 4 OH are possible, 2 with this phosphorus and 2 with this phosphorus. Now we are remaining with 2 oxygen atoms. So put these 2 oxygen atoms in between these 2 units. Again, this one is per oxo. So it is named as per oxo, consisting of 2 units, then diphosphoric acid. Phosphoric acid. Oxidation state of phosphorus here +5. Basicity 1, 2, 3, 4 hydrogen attached with oxygen, hence it is a tetrabasic. One point about those oxoacids which have pH bond, that oxoacids which have pH bonds are reducing agents, as they provide hydrogen to the other substance. Among all these oxoacids, H3PO2, as it contains 2 pH bond, is a strong reducing agent. So I hope you understand these oxoacids.